Good morning, good morning. That was a little loud. Yeah, there we go. That's better. Yeah, that works. Cool. Good morning. Good morning. All right. Let's get into it today. Let's see. What are we working with? Okay, cool. I think the things that we need to add today, we're going to add environment support so you can pass it like an end file and you can just do that. Or, I don't know. We'll consider it. I mean, Docker can kind of inject these, so maybe not. But yeah, we'll see. All right, let's turn down the volume on this side. Yeah, that's better. It's like it is really loud on my end. All right, cool. Let's get started. So the big plan for today is we're gonna do some packaging of this project with Nix. That's gonna be the fun part today. Which, if you've ever packaged a project, a Nix or a Go project with Nix, it's a less than ideal experience. It's pretty bad. So yeah, it's gonna be good. Let's get into it. I also think you will probably clean this up. Well, less than ideal. Exactly. Exactly. Some might say it's working as intended. That would be, you know, still learning Nix. Okay, yeah. I won't say that I'm an expert at Nix. I'm good enough to get by. I use it for most of my configuration. So like all of my shell configuration is through Nix. But well, not my shell. Everything else but my shell and NeoVim is. So Alacrity was. There's a couple other things. We can get into that at a later point in time. But like basically, Home Manager is not. It's great until you use something that's newer than it expects, and it doesn't really like that. So, um, yeah, let's get into it. So I can kind of show you what I'm working on here. We can do flake.nix. So this is a template that I took from a older um like Nix package that I maintain for myself. It's called Bunigi Go. It's like a personal Discord bot for my friends. We're gonna go ahead and like rewrite this today. So what we can do is we can do this. We're just gonna replace that with Gnut. Yep. Cool. What else we got? Go 121. Go please. So there's a couple parts. I think we're not gonna package it because I'm not gonna publish this yet. We'll worry about the Git stuff later. And then the big part here is you have to leave the hash empty, and we'll get to why that is in a second. Cool. A interface or managing your nut server. Also, to think about this, I was thinking this might be a good to expand the scope of the project eventually. We might add some support to do things like I lost my train of thought. Oh, we can use it to do actual like server like commands against the nut server. So you can actually run like actions. So for example, like it might beep a lot, so you can do something where it's like, oh, let's not, we can disable that. But yeah, that's kind of the thought is we could add some actions for that. Let's see. Yep. MIT licensed. This is not really a thing yet, but it'll probably be this. So just a little bit about like kind of what we're doing here. There's two parts to this. Basically, this one is only building a Docker image, but we can use it to build the native image as well. And let me show you how to do that. Builds the binary. Default packages make shell. I think there's a build go module 1.21. Yeah, there's a, let's see, fetch from GitHub, build go module. Yeah, I think that's all we need. It's like, is this master? Yeah, okay, good. Let's see. One I can immediately think of. What's a good tool? Go Swagger. That's a good one. Go Protobuf. I bet that one uses Go. Build Go module. Nope. Okay. So much of using Nix is literally just using it with like, oh, Go Flump. That might be a good one. Did they switch vendor SHA-256 to vendor hash? That's interesting. So much of Nix is just like literally. Oh, they did. F. Yeah, that'll work. Okay, cool. So we can do here. Let's, to keep in line, we'll change this to vendor hash. Okay. So what build go module does is it's going to do something that's kind of weird. So there's this vendor hash part that we need to do, and this will actually run, I bet, because we're not in a. Oh, you know what might happen though? Let's see if we can. I think it's build support. Go module. Yeah, so there is a potential that, like, I ran into this one on a Rust project. You can build a Go module that does not have, that won't include files that aren't related to the project. So that's what I'm trying to figure out. I think that would be under packages, compile. Is it? It's been a while since I've been here. Let's see. Let's see. That's not what I wanted. Let's look in issues. There it is. Is that GNOME? Yes, it is. It is GNOME, actually. Where was this file? This is the one. Yeah, so this is GNOME, but it's the like the Pop! OS version of GNOME. Yeah, so that is a plugin. Let me pull that up. Extensions. That is known as. I think I might have passed it. Spacebar. So it's a GNOME shell extension that allows you to do um, like you can use workspaces basically. Um, yeah, it's forked of this one, workspace bar, but I like this one a little bit better. It works pretty well. But yeah, you can still do like keyboard shortcuts with like Super 1, Super 2 to like switch between your workspaces. And if you have a window actually on it, so if I like move that down and I go like that, it doesn't have that weird issue. But yeah, I think that for a lot of times like GNOME can be enough. You don't need to necessarily go i3. I mean, I like it. I've used it before. It is pretty nice, but like sometimes I just like not having to configure it. I like just having yep, it just works. And that's what I feel about with GNOME most of the time. Yeah, for things that don't have exactly. I3 can get pretty chunky pretty fast. And it's like if that's what you want to spend your weekend doing, by all means, but I'd rather spend time writing code than actually configuring my desktop environment. I used to run Awesome for a long time. But I don't really run Awesome anymore. It just got out of hand really fast, and then I was like, yeah, we'll go back to GNOME. I am excited for the Cosmic desktop though. It looks like it's going to be pretty lightweight and it should run pretty well. But it is. It really is. You're just like I I just want to read my email. I just want to listen to music. Like I'm not. Yeah, I get that. And I was seeing the thing of like, well, just put it on a separate workspace and have it just take up the whole workspace. It's like, okay, but I don't want to have to switch workspaces necessarily on, if I have multiple monitors or something. That's also the thing. So like I'm using my laptop right now. i3 works really well on single screen, setups, but I find that it can get kind of out of hand when you're working on multiple, um, which can be a little crazy. So. Yeah, so let's go back to mix packages. Packages, I think it's this. Okay, packages, development. That's the one I'm looking for. Go EF, no, compilers is what it's under. Let's see. Go. Nope, that's the wrong one. Go 121. There's something I was looking for, and now I don't remember what it was. Interesting. So it bootstraps to Moozle, which is very fun. Yeah. There is this like weird. There is a weird bug with Pop! OS sometimes though, where it just like doesn't. Sometimes it can just lose a window, and it just doesn't. I don't know where it went. There it is. Yep. So, hello. Yep. It's not great. That's why I'm kind of excited for Cosmic. Like, I hope that they can kind of get their window model how they want it a little better. And I think that they just have the time to test it that other window managers might not. Hopefully. Okay. Okay, that's... What is going on here? There we go. Okay. Yeah, right as I'm singing the praises of using it, it's just breaks on me. Okay, cool. So, okay. So this is kind of a cool thing here. So if we do a Nix Flake show, this will probably break. That's fine. There's a reason for that. All right, cool. So if you see, we have a couple different packages here. We have a Docker image. We have the binary itself packaged. So the cool thing about that is I can do Nix build. And because I'm using ZSH, I have to do weirdness. We can just do Nix build. That'll do the default, which is this, which is going to be the binary. And it's going to say, oh, man, we found an empty hash. We're going to assume it's this. If you see, it's going to build with Go 120.8, which is what I was looking for. Okay. And bam, flake.nix. I think we have to do build Go module 121. That's what I was just looking at. Yep. So let's go to issues or PRs, I guess. So I bet there's one open for it. Okay. Oh. Go. Add Go platform for Go packages. Build Go. There we go. Let's actually look in issues. I wonder if I could just, because it is a package, build Go module. No. Okay. I literally just saw it. Let's see, history. This one. Build Go 121 module. Okay. Because that makes sense, you know. Sometimes Nix is just like the hardest. It's pretty hard to read, and it gets kind of like I'm like I don't know what I'm looking at right now. Okay, cool. Build Go 121 module. There we go. Now we're cooking. And then this allows us to use this to whatever we want. So let's do a Nix build. Yep, there we go. Go 121.1, which is actually newer than what I have on my system, I think. We can copy the hash, which is this is the downside of packaging these projects with Nix. So the biggest one is that you use a you have to do this where it generates your hash. So basically what Nix is doing, from what I understand, is it is going to attempt to build it, and what it does is it vendors your dependencies using Go mod vendor, which basically takes all of your Go dependencies and puts them in a folder. And then what you get is an output that is like a little more. You get that tree. Then what it does is it takes the hash of all of those dependencies, and then it generates that hash for you. So that's the biggest downside of this, is it kind of makes updating your dependencies kind of a pain because you have to do this. I haven't figured out a better way to do it other than like manually vendoring it myself and then doing it that way. But that is an option you have. So now, if I do a next build, it should compile, and I can do .result, then not test, and it's going to say it's not host, so we can do yeah, we can do this, and then we'll just replace this with results, then not test, and there we go. So now we have a Nix built package, which is cool. That's kind of the fun part here, right? So now that's running with Nix. Now that's not the coolest part about this. The coolest part about this is we get, due to how like Nix builds, we get the ability to build Docker images for free. But that is good though that it like packaged all my templates correctly. I was worried about that. So if you look at if there's any Rust developers in the chat, Crane Nix. If you look at Crane, there's kind of a weird thing that can happen where source filtering. By default, it does this crane lib clean cargo source, which is a good thing. What it does is it like excludes, it cleans the source tree to omit things like version control directories as well as omit. So like basically the problem right now is when we do this, it's going to package the whole folder, which is not ideal, you know? Like it'll pull in all of it when it does the build. So like we wouldn't necessarily want to do that when I'm, doing this on something like a, if I'm doing this for CI, right? Because I don't want to have something like my end file in there or whatever. And we can actually talk about building this in CI. So there's a cool project called Hercules CI, and we can kind of walk through that as well. I think it's just git CE. Yep. So this is a project I built called git CE, and it basically allows you to do git stuff, but it uses, and I'll show it in a minute when I start kind of using this, doing some git stuff. But basically what it does is it's a commit. It does conventional commits for you, and it taps into libgit2 to do that and do all that. But the cool thing about it is that we can, using Flakes, I have on my server here, we are running a Hercules CI node that we can use to actually update and test using just Nix. We can test all of our stuff here, which is pretty cool. So we get to do things like this. But like there was a point where I was trying to build something with Nix in this cargo source. Did not work. It did not work at all because basically it was filtering out. Actually, it was the LSP project that we were talking about last week. I was trying to build that with Nix, and what was happening is it was filtering out non.rs or .toml extensions. And that's by design. That's a good thing. We want that because it kind of allows us to focus down on like what does the package actually need. But the biggest downside to that is that we have, basically all of this. So, yeah. But we'll eventually use Hercules CI to kind of do this build too. So it kind of does things like this, where it'll update the flake and then it'll make builds. And you can see that here, I think. Yeah. Let's see if it'll let me in. Yep. So it'll do builds for you, and it can just build the whole thing, and then it'll do things like cache your dependencies and all. It's really nice. It was a pain to learn how to set up though. But now that I got it, the first time I'm like, okay, all right, now I got it. But yes. So this also gives us the advantage of having, we can do Nix develop, all the other fun parts. I can hop in and I can do like which go, and it's the one for this. So it's go 121.1 main.go. So that's cool. And it works with your existing, shell stuff, which is cool. So here's the cool part. So we can do a Nix build, the Docker container, and that'll just build that Docker. It builds a the compressed Docker image that you can do a Docker load. I think results. Yep. There you go. So now ImageNet already exists, and that's because I have a Docker file in here, but this one's going to be a lot smaller. So if we go Docker images, yep, clear. We should have one for that, so we can do Docker run. Yeah, but basically we can do stuff like that. That's kind of the advantage of doing so. But yeah, let's nvim.getIgnore. Let's just get this working. We're gonna add the .n file that's in here as that to the ignore. I think we'll remove. Yeah, we're just gonna remove the Docker file for now. I don't really need it. We can remove the Tailwind config because we're using a CDN version of Tailwind. We'll come back to that. I really don't want to get into that just because I'm really not feeling it. Honestly, we'll add the results. Get init. Git add. Git. Oh, so here's git commit engine, or git CE as it is. So you do a git CE. You can select your type, and it's also searchable. So you can go like feet, and it'll fuzzy find it. So this one will be feet. You can list your breaking changes, and you can say initial commit. It'll pop up in your editor. You can just save and quit it. Boom. Oop. Oh, hold on. Hide screen. Let's put the key in. Cool. All right. Cool. There we go. So now we're done. And I will get this set up on Git, actually. So I'll hide my screen one more time. All right, let's see. Let's make a new repository and get this set up. Yep. Okay. Okay, cool. There we go. And we're live. So there you go. Now we have that. Let's do a couple things. We'll add a license. I'll do an MIT license. Yep. Yep. Cool. Awesome. Cool, cool. Love the doc screen. Yep. That's a good one. It's a good one. Can't leak those keys, you know. All right. Cool. So now that's the fun part. That's ready to go. We should probably add a README. Git pull. There we go. Come on, let's cooperate. Good nuts. I guess I could do like what did I say? A simple client for managing your nut server. Usage. No, I actually didn't mean that. LaTeX LS, I really did not. We can do sh. So we can do go run -h. There we go. By nuts key, and I think by nuts host. Yep, nut key and nut host. Cool. Yeah, that's it. Ooh, I guess. Ooh, that's something we should do. Npm. We should allow it to specify the port in the interface. So. Interface. So this one we're gonna just specify as empty, and we'll see why we do that in a second. Interface. Cool. Okay. The default interface or the listening interface. Ooh. So in this case, so currently it's listening on all interfaces port 80. So what we'll do instead is we'll say, okay, this will be port. We're gonna say the default port is 8080. Actually, let's set this to just localhost. And we'll set this default port to 80. Actually, no. Let's do this so we can set those as environment variables. So get env. Port. Yeah. Cannot interface. Okay, so we're setting the host and the port. Now I can go down here and do output or okay, and then we can just put that here. And Copilot striking again, man. Give the typos. Oop. Cool. All right, so there's the interface. That's added. We're looking good. Okay. Okay. And then we do that. Cool. And we can do if host interface is that log dot fatal. The interface is not actually no, let's not do that. If the interface is not set, we're gonna we don't want to log it necessarily. Let's just set the host interface. It could be like this. Nope, this. Yep. Equals. We'll set this to localhost. So you always want to have a default. If port is empty, we'll set it to 8080. Yep. So in theory, I could do an just this. All right, and it worked. So there we go. And it still allows us to pull up all the data here, which is great. We should be able to do clients, and then we could do like interface. Let's do like a -h. Client. So we do like interface. That's not exactly right, I don't think, but let's just change the port. Port 8081. Dot. Yes. So if I refresh this, it's gonna fail. If I go to 8081. There we go, baby. There it is. That's what I'm looking for. All right, cool. Okay. Nice. All right. Main.go. Yep. Now you can specify it on whatever you want. Go run -h. There you go. The advantage to using something like this, where you put the environment, is if you set the environment variables and you run -h, it'll show you that in your terminal. So you can say like, oh, I actually set this key, and it's, you know, whatever. So like, yep, there we go. So we can do mvim main.go. Nope, readme. Let's do a pate. Super P. There we go. Client interface. Default is localhost. Uh, 8080. The key. Nut key. Default is the nut host environment variable. Okay, cool. Cool, cool. Yeah, looks good. So there we go. I think that looks good. There we go. And now we can go back to Gannett here. We could probably get something going with Git CE as well to get it, like, you know, generating packages. I do have a thing for that. We could generate little Docker images. Because we already have it ready to go. We already have the flake for it. You know, let's look at that. Docs. Yep, there we go. Okay. Netlify deploy, run nixops, run Arian, cachex deploy, write branch, run if modular. I know there is one. Write Docker key. What was this? Oh. So this is like writing a Docker. Use Docker host. For environmental to connect to a specified Docker. Oh, okay. I guess so that's so you can use it for deployments. Guides. Distribute a static binary. Which in theory it should be. You can check it though. Oh, next build. Ooh, that is building incorrectly though. Nvim main flake.nix. Okay, so it is weird that it's dynamically linked. Yeah, we'll have to look into that. Flake.nix. Where is it getting that from? Do I really need packages.ca cert? I might not need that, but come back to that. Package name is name. Why is it building to nut test though? Oh, I guess because that's the directory I'm in. Oh. Okay, so let's update this. GitHub account, Ethan Holtz. Good nights. We'll update that to Go 121. Go mod tidy. There we go. There we go. We don't need this, we don't need this, we don't need this, we don't need that. Go static binary. I know there's a way to statically compile and Go. Let's see if we can do it. Yep. Let's see. Go. Can I even do it? I don't know if I'm going to be able to build. Yeah. Okay. So for the flake, there is a way to set it. Let's see. Hmm. Okay. Set environment variable mix build. Yep. Okay, so it's using. Okay. Is it really that easy? Probably not, but I can dream. Go enabled equals 0. All right, so LDD. Let's go. So I don't know if we need to compile it with Moozle. Hmm. We could probably test that though. Hmm. Very interesting. Okay, cool. So now we have it non-dynamic. Um, go clean. Clean. Get diff. Wake.nix. Ce. Removed Go for static builds. I think in this case it'll be fine since we're not really like depending on anything external. So I think that should be okay. Do a git push. There we go. So then in theory, we can distribute a static binary. We can do GitHub releases based on this. We have identified, so yeah, this is eventually the goal. So you can use Hercules CI to deploy it. We'll need to do some testing on that though. We'll need to validate that it actually runs. How would I do that? We probably would want something with an older version of glibc, right? Because or just an older version in general. Because we're going to run it. Yeah, we can test that. I know how we can test this. We'll do that at another time. I need to spin up some infrastructure for that, and I do not want to feel like doing that right now. But I think what we'll do is we can spin up a piece of we'll spin up like a Rocky Linux server or something. I have one, but I need to like get everything over there. We'll spin up Rocky Linux, we can test it with that and see if it, I bet Rocky Linux has an older kernel than what I'm expecting here. We can copy the binary, see if it'll run, and then that should be sufficient, I think. And then we'll, the nice part is then we also have it in the container now, so we don't need any external libraries, in theory. So, yep. So the advantage to this now is that because we're using Hercules, we can use Hercules CI, is we get builds for all of these systems. So Arch, or not, ARM64 Max, ARM64 Linux, 64-bit Max, or x86 Max and x86 Linux. So we get both, which is cool, which is very nice. So that's a win. Let's see where to next. Yeah, so we'll do that later. We can add the other parts. Let's add a check. I always forget how to do it. Nix flake check. Yep. So we can add some Nix flake checks to do some validation. Format check. Do we really want that? Yes, we do. So we could go like a go test. What about go? Oh, we could do like go fumped. I don't think we really need that right now. I think we can in the future, but I don't think that it's something that's really necessary right now. But we'll get there. We'll add that at some point. Okay. All right, well, I think this is a good spot for this right now. We can work on the packaging stuff. There's just a couple things I want to validate that I think I'll probably do off stream. Let me make a note of that. I have my little to-do list here. Okay. Yeah, I wanted to add it publicly so that if anyone wants to contribute, they totally can. And we can kind of work through that. Yeah. So just feel free to pull it, fork it, do what you need to do. Whipped out the pen and paper. That's right. That's right. I'm very much a pen and paper guy. I love taking, like, when I have a thought, it's just easier for me to write it out than it is for me to type it out sometimes. For code, I can, it's easier for me to type it out, but for pretty much anything else, I'll write it out. So with that in mind, I was going to ask chat if you guys are interested. I have a Zig project I've been working on that's very funky. If anyone wants to take a look at that. If not, then we can look at doing LSP stuff in Rust. Don't know anything about Zig either? Okay, cool. Let's do it. All right, so this one's a weird one. This one is kind of unrelated. So this is, I'm going to be honest, Alcius, this is a project that I'm working on, and I don't know why I am. But it's an interesting one. So, there is, we can do like, is there a Zig clean? No. Yeah. So, Zig is interesting because there's a lot of cool stuff to it, and we'll get into that. Basically, the project is the following. There is a file type used by the scientific community called the PDB. It's for the protein data bank. So we can do www.pdb. It looks like this. This is the spec for it. And I can open up the largest PTB that I could find is this one. So this is an absolutely massive file. It has 140,000 lines. And what it is it's a representation of proteins that is stored by the protein data bank, is my understanding of it. It has a lot of information in it. It has a lot of different pieces to it. So you have things like what journal is it referenced in, remarks, where is it from, the authors. It has a lot of information in there, and this is like the standardized format used. There's another one. It's called the XPDB, or PDBX, I think is what it's called. But there's a lot of information in here, and basically, you use this file to read in. Now, there's a popular program called OpenMM. It's a Python tool used by like molecular modeling individuals to kind of run their simulations. Now, one thing that I have been absolutely keyed in on for the last week is how do we use this to how do we parse these files? Because I think that would be like a really interesting idea, and there's a couple reasons why this is interesting. Let's look up PDB file, Wikipedia. There's a reason why I was talking about this. So yeah, it looks kind of like this. Hundreds of thousands of lines. Yep, has a bunch of records. The interesting thing about this file is invented in 1976 as a file format. Okay, and what's really cool about it is a fixed column width format. So that means you can never have more than 80 columns because it was meant to be on punch cards. So the interesting thing that we run into is you can do some really interesting pieces of parsing because it's only 80 characters. I don't really know a whole lot of Zig either, I'm going to be honest. But I'm really interested in this coming from a C background. So what we can do is we can allocate this information. We can allocate the lines dynamically or almost statically because we know that each line is going to be 80 files. So like it can be a long time to like read all this in, read in the whole file, right? Because if you look at it, this is a pretty we can do ls-alh. This is a 114 megabyte file. That's a pretty decently sized chunk. That's a decently sized guy, So how do we read in this file? We can open up OpenMM PDB structure.py. And so this is kind of what this is the OpenMM structure for doing this. So it reads in the file. It decodes it as UTF-8, which I find to be very interesting because the spec makes it look like it's ASCII, maybe. How do you even come across this? Great question. My partner is a scientist, and they use this kind of file a lot, and I was just very intrigued by it. I was like looking at it, and I was like, that's a neat one. That's weird. That's kind of funky. So yeah, it's kind of a cool one. But basically, how Python does it is they do this like, hey, we're searching for this. We search for these different things. And we, they do this like line slicing stuff. Now, I think, in theory, we could get this to be a lot better. We could really improve upon this. And I have gotten it with minimal saving of data yet to be quite a bit faster. So that's a win. But let me show you kind of what we're working with here. So if you're unfamiliar with Zig, Zig is kind of weird in the fact that it has this idea of comp time compilation. So what does that mean? What is comp time? Comp time is basically that you can compile your code and it'll generate. It allows you to do something kind of like a macro where you can infer things about the program at compile time. Then it'll generate Zig code to be compiled at compile time. So this means this basically. So this is like an inline for. This is basically iterating through a struct and taking and setting the values dynamically at compile time. So that saves us from having to basically do something like this, where I would say like this record is these 6 bytes and serial is these 5 bytes, and et cetera, et cetera, et cetera. So that's kind of a weird thing. So what you can do is you can do it where the compiler already knows the field and it knows the type info, and you can infer all of that at compile time, which is cool. And then the compiler can handle that. But yes, so that's kind of the thing. So there's 2 different ways that I've been tinkering on this. Actually, let's update the stream information just so. Oh, wrong keyboard. Let's add a tag. Zig. There we go. Done. Updated. Cool. Okay, so there's 2 different ways we've done this. First, the first implementation of this was this one, which is a buffered stream reader. This is completely stack allocated. It does not touch the heap at all. So we're reading the file and parsing it one step at a time. Now, couple things to note. So a couple limitations and why we need to work on this. Currently, it only supports a single record type, which is atoms. So if we go to here, oh yeah, that's gonna hurt. So we go to like atom. It only supports this kind of record, this atom record. But as you can see, between this and the spec, there's quite a lot of other ones like this Anisu record and things like that. So what I'm trying to do is go through and parse this out to be more representative of what it is. So we know that like we're gonna parse this into whatever basically. So to start, what I'm gonna do is I'm gonna work on getting these records into structs correctly. So in this case, we have atom, which has this field. So basically how we parse this up is there's fields here, but like the one thing that's weird about this is there's sometimes where a field does not, there's a space or there's a lot of spaces. That file is 1.4 million records. Yes, it is. That is the fun part. That is why we're trying to do it. So I haven't tested it on that 1.4 million record line yet. And that is because it has more parts to it than what I am willing to work on yet. But we'll get there. Yeah. So this is so we have like spaces and things, and that's because, and this is where it gets even crazier. Not all programs that use this file format use it to the spec, and there's a couple popular ones that don't. So we need to be able to handle those cases as well, and that's something that the power of like OpenML has, is that it can parse the non-thing, those other cases. So, we're working on that. Okay, cool. So here's the kicker. Here's where we're gonna start. Is this part here? Oh, like why is that not working? So we know that the Adam record name is this. I probably don't need this, but we're gonna include it just for the case. The integer is 4 bytes. You have to write a program to multiple specs. Hopefully there's a way which file uses what spec. Yes. So luckily, what can kind of happen is a lot of times it's not necessarily that it's multiple specs. It follows the spec, and then what I was kind of referencing, that there are these holes in this spec. So if you look, there's a space on byte 12, right? So 7 through 11 is an integer, 13 through 16. Byte 12 is empty. So what'll happen is you'll have a program that uses byte 12 for data instead. Or you'll have something where it's like, oh, byte whatever, right? So what we can do is we can just handle that case where it's like, oh, well, if there's something there, it's probably this. But a lot of times that's the case that, we can do that. What we're going to do is we're going to try to provide a simple case where we parse just the spec first. That's the first one. Because those are, first of all, the www.pdb, so that file I showed you, that one was from the protein data bank. And that one is actually specifically for, like, those ones have to be to that spec. They're evaluated and tested for that spec. So we're going to have to do that. Did you get the space at column 21? Yes. So that's here. So we have residue name, chain ID. So if you look here, we have space, space 2, space 3, and then there's a really big one here between temp factor and element charge. So that's here and here. Yeah. So basically, like, I spent entirely too much time. So the thing about this is kind of a pain to parse, right? Because, like, you have to sit here and be like, all right, well, you would have to do something like this where I'm taking the value and dereferencing that slice at each point of this 80 character array. And we can kind of demonstrate this, actually. So if we do a Zig run, unable to evaluate. Oh, okay. Well, that's a first. That should work. Why can it not evaluate it? Oh. Right, because that's not how that works. So we can put that there. We'll delete this. Yank. Yeah. Yeah, we'll come back to that. We're not really there for that yet, so that's fine. And we can... Let's add a flag, too. So we'll do... Yeah, a nice part about Zig is it actually has, like, real booleans and stuff. Like, it has, like, actual types, unlike C. But you can interop with C if you want to. Let's see. Let's add a debug print so we can do something like here. So we'll go if debug. Did I add that at the wrong point? Yeah, I did. We don't care about this one. So this is, we'll come to the difference in a second. So the buffered stream allocator or reader is a, oh, I'm used to writing it like Go. I'm currently getting like Zig, Go, and Rust all mixed up, and it's problematic. So like this, if debug that, so now it should fail. Correct. Cool. And we can do, we'll set this to true, and I can show you, you know, it printing basically. That's good. That's a win. It's so crazy how much those prints, though, add time to it. So this is the number of nanoseconds. So it's like 2.5 seconds, basically, to parse. Not the file I showed you. That was printing 227L, 7L. This one, and this one has, you know, 77,000 records. So it's a pretty big guy. Which is, you know, it's a neat idea. It's a neat little thing. You can get it a lot faster by doing like there's some compile time optimization. So you do like Zig build. You can do like, you know, stripping the debug. Yeah, no reason to test on a larger file. Yep, 100%, 100%. Let's turn dark readers on. There we go. Yeah, no, so let's see, Zig here. I feel confident that we can get rid of this. I'm kind of scared to, though, but we can. There is a way to do kind of like an interface-like thing. I wonder if we could do like, so basically what a general purpose allocator is you can think of it like it's a heap allocator. So it allows you access to the heap. And then what we do is we are initializing an array list in this case. Whereas this one, the buffered stream reader, we use just a static array. So we're using an array that we're reading into, and then we just overwrite we reset the array every time. And that's kind of the goal, at least. So what are we going to do here? Well, there's a couple pieces. First, I want to parse these out into the right sizes. So this is an integer. We're going to say it's a U8 because it can't be larger than 8 bytes. Interestingly, the integer values can also be hexadecimal because it's an ancient file format. So we'll do name. So the Atom Records goal is to be a the goal of it is to not include any of the spaces, and it's supposed to be typed correctly. So like we set string equal to basically a constant array of U8, which is like a constant byte array. Okay, so we have name, we have alt location is a character. So yeah, that's just char. I don't think, oh, that's just a U8. It's just a byte. I think, let's see, does Zig have chars? Zig char? C char. Yeah, so we do have a C char, but I don't think I really want a C char. Yeah. The thing I do like about this is that it does kind of preserve that idea of like, you don't have types. So we can do something like this. Like we can say const char equals const U8. And that's okay. It helps if I can spell, though. Yep. Yeah. So this one we have to specify that it's a constant array because we know that it's like, we don't want to be able to change it. Okay, so we have this one here. So we can change serial to... Yeah, that's like a number. Out location, this is going to be a char. Residue name is going to be a string. chain ID is a char. Res sec is an integer, but like, okay, so it's 4 bytes, so we can say it's a U8. Oh, that's not exactly right. Because that's not the case. Because this is a integer that's 4 characters long. Right? And if it's hexadecimal, that could be up to 4 characters, right? Or 5 characters. Yeah, 5 bytes. So F, 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 F. 1, 2, 3, 4, 5. So it's holding a representation. Yeah. Yeah. So what, 5 bytes or 5 times FFF? I don't even. It's been so long since I've done any hexadecimal. To decimal. So that's 104 8575. So 1 million. Oh, so I think that's what, a U16? Oh no, not at all. U32, I think, is going to be. I think technically we could get away with like a U24, right? Like, yeah, no, we're not going to do that. We're going to use U32. I think that's going to be the biggest size we can use. So U32 here, and then for this integer, the res sec is also 4, so it's 1 less. So let's take a look here. $65,000. So can we get away with it? $65,535. That's it. That's the catch. U16. I'm curious. What's the primitive types they have? U32, U16, U64, U28, 128. I love that they have F80s. 80-bit floating point. That's very interesting. I don't even think I've ever used an 80-bit floating point. So we can use U16 here. Oh, wait. Hold on. Oh, wait. Residue sequence number. Okay, so that one makes sense. The one that... So real number. 8.3. I don't know what that means. But they're coordinates. Did I skip one? Yeah, I code. Char. I code. Char. Yep. Let's see. So I'm guessing... So these are the coordinates. Orthogonal coordinates for X, Y, and Z. So they're limited to three digits of precision, I'm guessing. Let's see. Okay. Yep. Yep. That's what I thought. Coordinates. Nope. Okay. Let's look up orthogonal coordinates. Yeah, this is gonna be. Oh yeah, here we go. This is it. This is the. Wow, you weren't kidding. Oh, they're non-Cartesian coordinates. I see. Look, we all know it was non-Cartesian coordinates. Come on. Come on. Yeah. Table of three-dimensional. What? There's a Oh. Wow. Thanks. I hate it. This is awful. What is going on here? Why? What am I getting myself into? Why am I doing this? What is happening right now? Oh yeah, there's another one. There's the CCD data format. That's a fun one. There's a bunch of different formats we can do. Crystal structures will do that. That's right. Exactly. Yes. Yeah, yeah, we're not doing that. We're not doing that. We're not gonna we're not working on any of that. So, let's see. Okay. Where was I? Atom. That's what we were here for. I think we could. I'm gonna say it's safe to assume these can't be larger than 3 decimal places. That looks. Oh, are you telling me that some of these aren't? Wait. Okay, let's look at this. Hold on. What's this? Anisotropic temperature factors. Love it. Love it. We're here. It's great. What the hell is this? Integer, what the, hold on. U field, U00. What is this? I might have gone too far this time. This might be my limit. Alignment of one-letter atoms, such as C, start at column 14, while two-letter atom names, such as Fe, start at column 13. Love it. I love it. I love it. I love it. It's great. All right, let's just continue on with this. Let's just say it's a float. We don't need double precision. You can use single precision. F32. There we go. Right? Can it be? Yeah, we'll just call it floating. Well, we'll call it F32s until it crashes, and then we'll up it to 64 if we need it. The rabbit holes we find ourselves in. You have no idea how big of a rabbit hole this one has been. Okay, this has been one that I've been thinking of for like over a week now, and I can't seem to break myself out of it. Occupancy. Yeah, I don't care. Floating point 32. Temp factor. Yep, floating point. It's fine with me. What the hell is an L string? Yeah, I don't know. And I think the hardest part about all of this is that it's pretty inaccessible. Like, they have the spec, but like unless you like, they don't tell you anything about it. Like, it's just kind of like, oh yeah, just you use it, and you're like, what? No, like there should be a little bit more resources to it. There's really isn't, which is kind of unfortunate. Because I think that we could really do some cool stuff here. So here's the part where this is gonna get kind of fun. So I think in a struct methods. Let's see. Functions Zig. I think there's a way that we can do this. Function. There's a way like function reflection. Wait, did they have function reflection? Very fun. Error defer. Function. Hold on. CD exercises. Yeah. If anyone wants to check out Zig, 110% recommend doing Ziglings. It is quite interesting. Struct. Oh, no, clear. ls. Okay, let's see. Structs. Check out the Zig what? It's called Ziglings. So if you go to ziglings.org, I'll post it in the chat. It's basically a resource where you can go and they teach you Zig by doing small like programs with it, which is pretty cool. Let's do mbim 037. I did this a couple weeks ago just to try to learn what's going on here. I know there's a way to apply it. Built-in, sentinels, values. Is there functions somewhere that I'm missing? Coded identifiers, floats, integers. Yeah. Values. There is a way to do this. I know there is. Yeah, kind of like exorcism. Exactly. Let's structs. Zig test. Values. Integers, arrays, vectors, slices, struct. There it is. So yeah, you can actually just add functions to structs, which is kind of a neat idea. So we can do a like pub func convert to atom record. Oh, yeah, the Zig language server is not great. I'm gonna be honest. It is functional, but it is a little tough. Okay, cool. Expected return type. So we're gonna return a atom record, and it's gonna take a reference to self, which is self. No, which is a line. And then can we do this at comp time? Does Zig have classes? I'm not sure I see the point of a class if you can add functions and structs. Zig does not have classes. So Zig is closer to C than it is to C++. Yeah. Yeah, it feels kind of like Go too in some respect, but not really. It's like it's like C, but it also isn't like C at all. If that makes if that's helpful, if that is helpful. Uh, let's see. Type coercion. Integer and float widening. Float to an int. Is there like string or let's see, float. Oh, oh, hold on. My monitor froze for a second there. That was weird. Okay. Float literals. Float literals have type comp time float, which is guaranteed to have the precision of operations of larger floating point type. Okay. Float literals coerce. Math, not a number. Floating point operations. Operations, that's cool. Precedence arrays. Is there like, okay, Zig autodoc. Float. Parse float, that's what I'm looking for. That's not helpful at all. All right, so let's see what. Yeah, all right, let's try what Copilot had to say. Let's see what it says. Ooh, let's try to float. Nothing. Okay, yeah, let's see if this works. Oh, that would compile. So that's not really. And I guess the question is, should I do this at compile time? Or like, should I do this while I'm parsing it? Maybe. Buffered right streamer. So let's, once we're done, we're going to do line dot convert to atom record. So we'll say var record. Yeah. So let's do record dot name. Yeah, we can just do this. Cannot dereference pointer of non-pointer type. Yeah, why would we need to dereference the pointer? Wouldn't we just want a copy of it? Come on, Copilot, that's weird. Yeah, that's what I thought. Okay. So we would get the address. Cannot dereference non-pointers. Okay, so... Wait, which one was that one? Okay, yep. So here's the biggest thing I found with this too, is that Copilot is often wrong with Zig. It just does not... I'm tempted to just disable it entirely on Zig files. Nope, I can't type today. So we take the reference to that. Is that right? Let's try that again. No field. Is that really a function? Try to... Yeah, that doesn't... You do have to pay for it. I get it through work, which is pretty nice. But yeah, you do have to pay for it. I've heard so you don't have to pay for Kodi, which now does have NVim comp support, which is through SourceGraph. So if you want to give that one a try, that one might be good. I did it a little bit, but I kind of like Copilot a little better. But if you don't want to pay for it, that might be a good option. Um, let's see. Let's go back here. Integer. Convert. Can I just cast it? What is this? Try to... Yeah, no, we're not doing that. Yep, no, I get you. I 100% understand. I get you. No, Copilot, stop. Don't... Okay, there has got to be a way. Convert. Oh, I think I just passed it. Int. Oh. Okay. Is that what that is? At int from pointer and self dot serial. Yeah. So Zig has these built-ins. Unsigned 32-bit cannot represent all possible unsigned 64-bit value. What? Converts value to a usize, which is the converts value to a usize. Unsigned 32-bit int cannot represent all possible unsigned. What the? Okay. Let's look at the built-ins. So we have int int cast. What is this? Converts an integer to another integer. Nope. Int from bool. Nope. Int from enum. Nope. Int from error. Int from pointer. Converts value to a usize, which is the address of the pointer. Sounds awful. Why would I want to do that? Converts an integer to another integer while keeping it. Oh! Int from float. Converts the integer to floating point. Mem copy. This is giving me some serious problem here. Let's see. Yeah, that does sound awful. Yeah. Converts value to a usize, which is the address of the pointer. Okay, hold on. Convert array or slice. All right. Zig. Convert string to int. There we go. How do I parse an integer from a string? Try standard format to parse it. There you go. Parses the string. Oh, and it can even imply the base too, which is nice. When base is 0, is examined to detect the true base. Interesting. Okay. So then in this case, it would be standard format dot parse int. Parses the string. So this is going to be U32. Yeah. Okay. The buffer, which is and self. I guess I don't really need that. I can just do self dot serial of I guess for this one we'll set it to 0 because we want it to invert because it could be hexadecimal and or it could be base 10. So it could be octal. Oh lord. What have I done? Okay, name. This one is just this. You just dereference the pointer. This one, alt location. All right, alt location is a char. So I think we should just be able to cast it. Residue name is also just a string. Chain ID, char. Cast it. How did it think? I guess, so here's the problem is, like, I feel like it's just, like, Zig has changed enough that it doesn't really know. Is there a parse float? There is. Parse int takes a U16, right? So we could actually do this where yeah. I think we could do this with comp time too. That would be kind of cool. Yeah, it's gonna take a while. Yeah, to get out there for proper. Yeah, yeah. But also, I think it's not even just that. I think it's just that Zig's API is, you know, their standard library has changed a couple of times, so we kind of have that piece where it's like, well, so this is going to be base 10. Yeah, it's definitely confusing. So like even Zig, the Zig language server gets confused, like sometimes it just doesn't. Yeah, it gets a little lost and, you know, doesn't know what it's doing. I was curious to see if BG is gonna stream today, but he might not. Standard format dot icode. Oh, that's a char. So yeah, the thing about Zig is it's good about Copilot is it's good when you have context. So like it picked this up because it knows like, oh well, he meant it for this one, so he, you know, which is pretty good. So this one would be standard format. Oh, I know this is gonna break. It totally is. Because if we get a parsing error, it's gonna fail. I bet. Let's see if it even builds. Yes. Yeah. Yeah, it has unions in. I always forget about unions. Like they are in C, but they're not that used, but they are very used in Zig. Hmm. Let's see. Let's see. Injures floats. Okay, we're looking for unions. Oh. I think this should work. Hers. Hey, look, it's exactly what I was looking for. Catch error. Actually, we don't care about catching it. We can just... Oh, yeah. Okay, so this actually needs to do this. So it's going to return that. Oh, yeah. Okay. So we have to rethink this because these are going to... These could potentially fail. Standard format. Oh, what? Oh, it doesn't need that. Okay. And I guess these probably need to be like this. Excuse me? Why? Why are you doing that? They're exactly the same size line. Weird. Oh, okay. Dot occupancy. Oh, these all need to be tries. So oh, this is a string. What am I doing? Okay. Cool. So basically, what we added here is we added this little exclamation point, which is like kind of like a catch. So like it's basically like if we're gonna try to run this thing, if it creates an error, it'll error and return the error value instead. So what we need to do then is we need to go down here and we'd say try this, and this is now an Atom record. Oh. So those are my, let's see, one value. So that would be, I think, chain ID, alt location is the first one. So we just want the value, I guess. Oh, duh. Why don't I just... Expected type U8 found const. So this. I just want to coerce the type. Cannot dereference a non-pointer type. Because this... Oh, this is dereferenced, so... One of those errors was on chain ID, not on alt location. Oh, interesting. So, alright, so let's... Was that where that error was originally? Okay, so we should have it here too. And it was working on the chain ID. One of your configurations for alt location worked, and it was working. Oh, okay. That is weird. What do I have? Is this a const? Interesting. Do I just coerce the type? Type coercion. Explicit casts. That's what I'm talking about. What is it? Convert between pointer types. What's a pointer cast? Use const cast. That's what I want. Remove a const qualifier from a pointer. expected type const u8. Oh, because I just did the complete wrong one. Okay. It's this one. At const cast. This is the one. Do I need to dereference the whole thing? Can I even do that? There we go. Okay, cool. Chain ID at const cast and self dot chain ID at 0. Yep, and the last one is the I code. No field in main.line. What is this? Temp factor? What am I doing here? Self dot temp factor. You know, here's the thing. I am also very confused. So let's just get that straight, okay? So I think what it is the const cast. I feel like this is dangerous though. Like I'm gonna do it, but I don't feel good about it. Let's just be very clear on that. So I appreciate it, but I feel like I'm playing with fire right now. But yeah, basically, yeah. So if we look at it right, this is returning a constant value. This is returning a constant pointer, or yeah, this we dereference the array to get the the pointer to 0, right? So we get the pointer to 0, and but it's a constant pointer, so we remove the constant, and then we want to dereference the value. I think. Oh, there we go. That's it. It failed. Parse int. Oh, is that just the first line? Did it just fail? Oh, serial. Oh, no. Okay, so let's do this. Standard, debug, print. Okay, yeah. We want the serial. See, like I said, we're not out of the woodwork yet, you know. Line dot serial. Huh? Excuse. Oh, we can just do this. We don't need to specify the type. Tuple structure found. Oh, yeah. Yeah, Zig does this weird thing where, like, technically you're passing a tuple of the arguments to be printed. So you have to, like... yeah, let's just print it as a string. Invalid character. What the hell? Hold the phone. What is going on here? Okay. Okay, so... Oh. Oh. So this is a good one. This is a good one. This is a good error here. Okay. So basically, what's happening is we are parsing a serial that's 5 bytes, but there are spaces. So let me. I think I can show this. Let's see. Let's take this. I think I could get it to crash down here. Let's do. Let's just do it here. Nope. And then what we'll do is we can do this. So basically, it's like 1, 2, 3, 4. 1, 2, 3, 4, 5, 1. Yep. Oh no. Okay. Bar val equals standard dot. Yep. I don't. Why did I use format standard debug? Yep. So it couldn't parse the space. So we need to strip all the spaces out. Okay. Let's see. Space. So like a white space. Ooh, yeah, exactly, exactly. So how would we do that? Oh, well, these would be empty bytes, right? So, oh man. Oh. That's a good point. Split. Good call there. Good call. Okay. So let's do this. Var string test 1, 2, 3, 4, 5. 1 is that. And then if we did like split any split returns an iterator that iterates over. I don't want an iterator though. I just want split scalar. Turns an iterator that are separated by delimiter. Can I tokenize it? Turns an iterator. No, yeah, we don't want to tokenize it. That's too much work. So okay, so then in theory we could do like var new iter string test no split standard mem split any is going to be a gonna be u8s. The buffer is string test, and the delimiters would be just a space, right? While iter.next item. Oh no, it that is the advantage, is you do get a lot of that, which is kind of cool. So here's my only concern, though. If we have to do that on every line, on every 6-byte character, like if we have if we have 5 bytes allocated to this, and only one of them is yeah, that's not gonna be performant. Exactly. Because then we're gonna have to loop through all of them. So I guess we would probably bit mask it if I had to take a guess, right? Because we would have like if we have like 0, 0, like spaces would be nothing, right? Would we bit mask it? Hmm. I think there's a way around this. Hmm. How do we do this? Because here's the problem. Remember how I was saying that like sometimes in other formats they take use of those spaces? When we do that, what could happen is you could potentially have 2 values right next to each other. So we can't even just take the entire line and split it on spaces. We have to like take the parts, you know? Hmm. Oh, okay. Yeah, it does. It really does. Hmm. So like space. We already looked at that. Uh, uh, strip spaces Zig. Nope. Is there? Oh, let's go. I was like, is there really? Remove white space from array. C. Let's look and see. Hmm. Same tree. Let's see. Oh, Python. Oh boy. Checks for space and then ignores it. Yeah, that's not great. So ideally what we would do is we could do like a read from the right-hand side, right? Because if it's like one would be like the least or the most significant bit would be 1 in this case, right? Or the least significant bit. I always forget. So would we read from the right-hand side, and we could say like, oh, okay, this is what's the ASCII for 1? Yeah. So digit 1. Char decimal. So the hex is 31. Could we just bit mask it? I have a feeling it's gonna be a bit mask. You know, let's look at. I'm curious. Zig format source. I wonder if they have it in here. So wait, I'm curious then. Does this parse? No. Wait, so does only this then parse? No. Where's the invalid character? Okay, hold on. Oh, because I wasn't actually doing this. So it'd be like U32 string test. That does parse. Okay. Okay. Yeah. Okay. So wait, did I read that right? Hold on. Wait. Serial 1. Oh, okay. So let's try this. Interesting. So spaces. Can I? Print as hex. Like, can I do like an H? Is it B? Can I do a B? What if we just iterate? Hold on. Let's try this. While string. Can't we just do like a while? It's a split iterator. We don't really want that. I guess this would probably be UTF-8. I have UTF-8. We can open it though. Yes, it's UTF-8. All right, UTF-8 space character. In binary, it is this. Okay. So what I'm thinking is we could potentially do this. We could say, so it's actually 0, 0, or so basically we see a bunch of 0x2 zeros, right? Because that's the hexadecimal. All right, so parse print hex sig. Oh, you already look at this? Okay, so let's try this. So let's parsing the int. So we don't want that. We want to do standard debug. Standard format slice hex lower instead. Okay. Three zero 3031. Why is that? Unicode UTF-8 table. So what's 30? Digit 0. Oh, yeah, that makes sense. That would make sense. Um, so what we could do is... Okay, so... Bit masks. It's been a while. I think Wikipedia has a good explanation of bit masks, if I remember correctly. Bits to 0. So basically what we want to do is we want to convert the 0x to 0 to 0x30. And we would do that by okay, so yeah, that makes sense. So 0b 1 0 0 0. And then 3 0 is yep. Interesting. Hmm. So what if okay. So when we have this, let's convert these all to spaces. 1, 2, 3, 4, 5. Yeah. 2 0 2 0 2 0 2 0 2 0. 3 1. So if we do a bit mask to Unicode, convert space to 0 bit mask. What Linux is this? Great question. This is Pop OS. Okay. I'm gonna have to think about this one. I think there's a way to do it. I just don't really know. Let me check something real fast. I think the hard part is we're still going to need to iterate through all the bytes, right? So if that's the case, then using the iterator makes sense. What is my spec? Great question. Let me see if I can pop this up. Um, Here you go. I can pop this up for you. Yeah, I think we're gonna need to. Sure. I think we're gonna need to do some sort of. I think we're gonna have to iterate through it, right? Because like I'm thinking about it, I'm like, oh well, we could like bit mask it and convert all the spaces, but it's like, but if we have, there's no way to know, right? Like we'd have to. What is the type on the serial? What do you mean? On the serial variable, what type is it? Is it an int or a string? Um, the serial variable, when we parse it, is a string of U8s, but we're converting it to a we're parsing it to an int. I wonder though. Let's see. What if it's? I wonder if it's just like because it's doing the assumption. Like if we do like what if we did like this? Does this parse? No. Yeah, so technically it's a string, but it's like a C string. So, but we cast it to an int to get rid of the space under the hood. Hmm. Yeah, but that wouldn't really work, right? Because it's a UTF-8 string. So it's not like a UTF-8 string looks like the number 1 would be like where is it? So it would be like this, like a 31. Yeah, that's what I was thinking too. I was like, oh well, we could just cast it to an int, and it's like, well, not really because it's parsed to be a int. Like it's parsed out as this, so it'd be like a UX31, which wouldn't parse to a number 1. Yeah. What if? Hold on. Let's let's try doing the conversion to like yeah. So let's try this. Pub func remove spaces. Remove space takes in a value, which is a string, and oh man, is it a string though? No, it's not a string. We're trying to. Well, it might be a string. We'll try it. That's right, 4. How did we do that before? Did we just split on the string? Oh, hold on. It froze. Hello? Yeah, my capture card's sometimes going to get a little weird, like where it feels like yeah, there it is. Now we're good. It'll just like freeze the display a little bit. I don't know what that's about, but. So here's what I think it is. I think what we'll do is we will try the iterator. I don't like it, but maybe, but then again, this could be a thing where, I guess we parse the fields, right? So we could do like, okay, Zig ignore white space. Let's see. Let's see. Oh, okay, yeah, that's not important. We don't care about that. Okay, fine. Yeah, yeah. Is it still crashed? Or is it back now? You see it okay? All right. I think I will come back to this. I think what we'll have to do is we're going to have to iterate through it, though. Well, what is the 0 character in UTF-8? So, like, what's just the value 0? Is it anything? Is it going to care? Oh, it's a control character. Yeah. So I think we'll just have to iterate through it. So we'll just do if. Yeah, I don't know. I'll think about this. I think we're gonna need to do something though to cast this like away. But luckily we're gonna. I will. Oh, I see. It is a little unstable. Am I just like running out of memory or something? All right, I think I'm gonna go. Oh, we're back. Weird. Okay. All right, I'm gonna go ahead and we're gonna go raid someone. I think we're gonna raid the Zig guys. Actually, to be honest, I need to go take care of a couple things, but let's see who's online. Oh, let's reopen that up. Let's see. All right, let's do a little raid here. Yeah, so Christoph is he's a it's a good one if you haven't been there. Would recommend. He is one of the Zig maintainers, so we will head over there. But I will see you over there. Yeah, take it easy. Where is the button? There it is. All right, cool. See ya. Thanks for hanging. I appreciate it. And take it easy.